Alright guys, today we're going to continue looking at absolute value graphs. This time we're going to be looking at changing the steepness and the reflection. So before I even do anything, what I want you to do is I want you to pause the video and see if you can graph these two parent functions without any help. Alright, go for it. Alright, a couple things to remember. The linear function has a slope of 1 over 1, and it has a y-intercept of 0, 0. Absolute value is a vertex of 0, 0, up 1 over 1, and always up 1, backwards 1 to make the v. Now, let's look at what happens if I were to change the function a little bit. What if I did y equals 2x? Well, if you remember from last unit, this is your slope. So I'm still at 0, 0, and now I'm going to go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1, and I get my straight line. That is the difference. You can see that this red line is steeper than the green one. So if I came over here and had y equals 2 times the absolute value of x, it does the same thing. It changes its steepness. The vertex is still at 0, 0, but now I'm going to go up 2 over 1, up 2 over 1, and I've got to make a v, up 2 backwards 1, up 2 backwards 1. And you can see once again that the red line is steeper. So when you multiply the parent function by a number, you change the steepness. Doesn't matter if it's a line or an absolute value. Because it's an absolute value graph, this number is the slope. So let's do a couple more. I've got the parent functions on there for you. I've got y equals absolute value 3 times the absolute value of x. Again, this is the parent function. This is my steepness. It tells me that it's going to be steeper than the parent function. I do not have any horizontal or vertical shifts like we did the other day, so I'm going to start at 0, 0, only now my slope is 3 over 1 and negative 3 over 1. So I'm going to go up 3, right 1, up 3, right 1, and then I'm going to go up 3, left 1, and now I've got my V shape. And you can see that it is steeper. Okay? Alright, now I come over here. What do you know about this number? This number is less than 1. So that means it is going to be less steep than the parent function. Okay, its rate of change, or its slope, is 1/3 and negative 1/3. So again, I'm going to start at 0, 0, because there's no side to side or up and down shift. And I'm going to go rise 1 and right 3. Rise 1, right 3. I could do it again if you needed to. Rise 1, right, left 3. Rise 1, left 3. And you can see that this absolute value is much less steep than the parent function. It'd be easy to walk up and down this graph, where it'd be a little bit harder to walk up and down this one. It's a lot less steep. So when you multiply by a number, you change the steepness. And that's what we want to talk about now. We've got the parent function, y equals absolute value of x. That's the parent function. And we have our new function, which is what happens when we multiply by a number. Okay? When we multiply by a number. When we multiply, we change the steepness. Okay, it's extremely important to remember. The bigger the number, the steeper the graph. This is not just true for absolute value. This is true for all functions. When you multiply by a number, you change the steepness. So I want you to go ahead and try these, pause the videos, and give it a shot. If you're not quite sure, go ahead and watch the first one and then try the second one. Alright, here's the first one. The vertex stays at 0, 0, but my rate of change is 2 over 1. So it's steeper. Go up 2 over 1, up 2 over 1, up 2, left 1, up 2, left 1. And there's your graph. Now go ahead and pause the video again if you haven't done the second one and try it yourself. Alright, on this one, the vertex is still 0, 0 because there's no adding or subtracting like yesterday. It's less steep this time because the number I'm multiplying by is less than 1. The rate of change is 3/4 and negative 3/4, so I go up 3, forward 4. I go up 3, backwards 4, and there's my V. Now we're going to look at reflections. Reflections are formed when you multiply by a negative. Okay? If you multiply by a negative. So if we look at this guy, we know his vertex is still at 0, 0 because there's no adding or subtracting. But I'm multiplying by a negative 1. So my rate of change is negative 1. So I'm going to go down 1, right 1, down 1, right 1. And then I can go down 1, left 1. What you notice is this graph is the exact flipped version of the parent function. Right? It's the exact flipped version. That's what we call a reflection. It was up here, and then it flipped over. That's called a reflection. So when you multiply it by a negative, it reflects the graph. So I'm going to look at this guy. His vertex is 0, 0. Okay. But he's been reflected. How do I know he's been reflected? Because he's being multiplied by a negative sign, and the rate of change is 3 over 2 and negative 3 over 2. So I'm going to start at 0, 0. Because it's been reflected, I'm going to go down 3, right 2, down 3, right 2, down 3, left 2. You don't have to do those additional points. I'm just showing you, if you had a bigger graph, what you could do. And again, it's been reflected because I multiplied by a negative. So it's pretty simple. Reflections. We've got y equals a times the absolute value of x. If the a is negative, the graph is reflected. So instead of being here, this is y equals the absolute value of x, it's down here. Okay, so if you multiply by a negative, it's flipped, or reflected is the word we like to use. And try to do these two. Pause this. Try to do number 1. If you're not sure, go ahead and listen along, but then try to do number 2 by yourself. This graph has a vertex of 0, 0 because there's no adding. It's been reflected because I've multiplied by a negative. And it's less steep because I'm multiplying by a number that is smaller than 1. 2/3 is smaller than 1. I don't look at the negative for steepness. Negative tells me it's been reflected. 2/3 tells me that it's less steep. Again, if you haven't tried number 2, go ahead and pause this one so you can try it by yourself. If you had tried it, just keep watching. And once again, I look at this. I notice there is no adding or subtracting, so my vertex is at 0, 0. I have multiplied by a negative. That means it needs to be reflected or going down. And I've multiplied by a 3, which means it's more steep because it's bigger than 1. So I went down 3 over 1 and down 3 backwards 1 to get my slope. And if you look at these two numbers, yeah, they're both negative, so they're both going down. This number is a positive 2/3. This is a positive 3. Positive 3 is bigger than positive 2/3, so the graph is steeper. The negative just means it's going down. All right. So here's a question. I'm going to ask it, and I'm just going to give you some time to think about it. Try to come up with your own answer, and then we'll talk about it. Which graph do you think is steeper and why? Is F steeper or is G steeper? Okay. Have an answer yet? Either one you picked, I'm going to go ahead and show you the graphs. These are the two graphs. You should know which one goes with which. The blue graph goes with this guy. I know that because this is a positive 2 and this one's going up. And then this is the red graph. I know that because he's going down and I have a negative. Which of these two graphs is steeper? The red one is. It doesn't matter if you're which way you're looking at it. This is the steeper graph. So when I'm looking here, it's not about the negatives or the positives. 2 is smaller than 5. The negative just tells me that it's going down. That's all it tells me. So when you're looking at negative, this tells you it's reflected. When you're looking at steepness, you only look at the numbers. You do not look at the negative sign. That's extremely important. So again, negatives do not affect steepness. Negatives affect up or down. So only look at the numbers when looking for steepness. Now let's try to put it all together. First thing I want you to do is describe the transformations. Before we even graph, you do have to describe the transformations. So if I focus just on this half, right here, I see a number being multiplied. What does that tell me? Well, I know it's not reflected. Okay, it's not reflected because it's a positive number. I know that I'm multiplied by 4, so I know it's steeper with a rate of change of 4 and negative 4, 4 over 1, and negative 4 over 1. But now I've got these things in here. This is what we saw yesterday. If the number's on the inside, that means that it got shifted to the right 1. And if it's on the outside, it got shifted down 3. Well, I was at the parent function's at 0, 0. If I go right 1 and down 3, that's my new vertex. So if I look at here, I can tell my vertex. 1, negative 3. Then I look at it, I'm not reflected, but my steepness is 4 over 1. So 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. And I got to make a V. Up 4, backwards 1. Or backwards 1. Then you should have a nice V shape. Alright. Did not draw that very straight. Hopefully you'll do a better job than I did. Let's look at the next guy. And got lots of numbers going on here. Okay? We went to picture it one by one. What do you notice first? I have a negative sign. I'm multiplied by a negative. That means it is reflected. It means it's going to be pointing down. I'm multiplied by 3 halves. Is 3 halves more than 1 or less than 1? It is more than 1, so it's going to be steeper than the parent function. And its slope is 3 over 2 and negative 3 over 2. And then I have 2 numbers here and here. The number in the inside tells you left and right. Because it's a plus 2, that means we're going left 2. And because it's a plus 3 at the end, that means I'm going up 3. So my vertex is going to be 2, comma 3, because I went left, or negative 2, sorry. So I went left 2, up 3. So there's my vertex. That's the starting point, the vertex. My steepness is 3 over 2, and I know it's reflected, so that means I have to go down 3 over 2. Down 3 over 2. Then you got to do the same thing getting the V. Down 3, left 2. Down 3, left 2. I ran out of room. You do not have to graph that if you do not want to. If you want to put it in there, you can. So there you go. That's putting everything together. We looked at reflection, we looked at steepness, we looked at left or horizontal shifts, and we looked at vertical shifts. All right, now we're going to practice writing the two equations. It uses everything that we just talked about. First thing we need to figure out is what our steepness is, what our reflections are, what our shifts are. If I go ahead and look at my steepness, okay, if I decide to look at steepness, I can come over here and say, I went up, here's a point, here's a point, here's a point, so I'm looking at nice points. I went up 1 over 2, up 1 over 2, up 1 over 2. So my steepness is positive 1/2 and negative 1/2. Is it reflected? No, it's not reflected. So that means I'm going to start with just y equals positive 1/2 times the absolute value of something. Let's look at my shift. My shift was here, and I went left 4. I went left 4. My vertex is at negative 4, 0. So if I go left 4, what does that mean? How do I make something go left 4? I have to do it inside here. So it's x, is it minus or plus? Plus 4. Did I move up or down? No, I didn't. I stayed on the x-axis, so there's nothing here. So if you see this equation, this has a vertex of negative 4, comma 0. Negative 4 from here, 0 from the outside. Let's come and look at this graph. Let's find the steepness again. Here's a point, here's a point, here's one, here's another one. Let's look at our steepness. Down 2 over 1, down 2 over 1, down 2 over 1. So now my steepness is negative 2 over 1 and 2 over 1. It is reflected because it's going down. Okay, it is reflected going down. Now let's look at the shifts. My shifts, I went right 5 and I went up 3. I went right 5, up 3 to get the vertex. The vertex is at 5, comma 3. So if I'm going to make my graph, or my equation, the first thing I need to know is that I'm reflective. So that means I have to have a negative number. My steepness was 2. Absolute value of x. I went right 5. How do I go right 5? That's a minus 5 on the inside. How do I go up 3? That's a plus 3 on the outside. I'm using everything that we've done together. Well, that's the end of the video. Hopefully you learned something and you're ready for class tomorrow.